Hello everyone, welcome. This is your fifth chapter, the client server paradigm. So in a client server architecture, a computer is called a server if it is dedicated to managing resources, switches, printers or files so that other computers called clients can access those resources through the server. So in a client server architecture, a computer is called a server when it is dedicated to its clients. That means it should provide access to its resources like switches, printers or files so that other computers named clients can access the resources through the server. So the diagram shows the client server architecture and server host and client host. Client host is having its client process and server host also having the server processes and multiple services. So client host can access the services through its client processes. They access the server processes and server process provides the service. So the server process runs on a network connected computer which referred to as the server host to manage network service provided by that host. Okay, server process runs on a server and the client host makes use of a client process to access a particular service. It is possible for other client processes to run on the client host at the same time, but appropriate client must be used to access a particular service. So the client host makes use of its client process. So client process resides in a client host to access the particular service. So it is possible for the client processes to run on the client host at the same time. Okay, so the same multiple client processes may run on a client host and it should access the appropriate client must be used to access a particular service. So there are few client server paradigm issues. The first one is a service session. A term session to refer to the interaction between the server and one client. So the interaction between one client and a server is called a session. The service managed by a server may be accessed by multiple clients who want to use the service, sometimes concurrently. Okay, so these clients can access the server sometimes concurrently. So each client, when serviced by the server, engages in a separate and independent session with the server, during which the client conducts a dialogue with the server until the client has obtained the service it desires. So to get any service, the client performs a dialogue with the server. Okay, so the figure illustrates the execution flow of the server process. Once started, the network server process runs indefinitely, looping continuously to accept requests for sessions from the clients. For each client, the server conducts a service session. So see the diagram. First it starts the service and next it accepts the client's request for a session and conduct a session with the clients, and again the arrow is gone backward to accept the client's request. So the server may accept or loop the client session until the desired service is provided. Okay, so the next issue is the protocol for service. A protocol is needed to specify the rules that must be observed by the client and the server during a session of the service. Okay, so the interaction between client and server is called a session. So during this session, there are certain rules must be followed by the client and server. So the such rules include specifications on the first one, how the service is to be located. The second one is the sequence of inter-process communications. Third is the representation and interpretation of data exchanged. The first one is locating the service. The mechanism must be available to enable a client process to locate a server for a given service. In the simplest scheme, the service location is static and can be identified using the address of the server process in terms of host name and protocol port number assigned to the server process. So the locating the service means the finding out the exact location of the server. So it is done by the giving the address of the server process and identifying the protocol port number of that server process. So here this is the scheme used for internet services, where each internet service is assigned to a specific port number. So internet service like FTP, HTTP or Telnet is assigned a default port number that is reserved on each internet host for the service. So for example, the FTP service is assigned two port numbers, that is TCP20 and TCP21. So HTTP is assigned to the TCP port 80. So these are the numbers: TCP20, 21, 80 are the numbers, protocol port numbers, and FTP is assigned to TCP20 and 21. HTTP is assigned to TCP port number 80. So at the highest level of abstraction, a service may be identified using a logical name registered with the directory or a registry. The logical name will need to be mapped to the physical location of the server process. If the mapping is done at runtime, then it is possible the service's location to be dynamic, in which case the service is said to be location transparent. So here the logical name must be mapped to physical location at runtime. So it will be possible. It is possible to be a dynamic location. Okay, the service will be the service location will be in a dynamic manner. Okay, so this is called a location transparent. The next one is inter-process communications and event synchronization. So in the client server model, the interaction of the processes follow a request response pattern. So here client server, that is always request and response pattern. During a service session, a client makes a request to the server which replies with the response. The client may make a subsequent request, okay, subsequent request followed by a reply from the server. So client makes a request and server gives the reply or response. For each request issued, a client must wait for the reply from the server before it can proceed further. For example, one of the simplest network services, the daytime service, whereby a client process simply obtains a timestamp from the server process. So daytime service is, for example, daytime service. So client makes request for a timestamp. Okay, using this daytime service, the client makes a request for timestamp and the server provides the timestamp. Okay. A dialog during a service session of this protocol proceeds as follows. The dialog will be like this: client sends request like, hello, client address here, may I have a timestamp please. So client is requesting for timestamp and server, here it is timestamp follows. So the server provides the timestamp. Okay, the dialog in www session proceeds as follows: client, hello, client address here, server, okay, I am web server, client, get me web page index.html, server, okay, here is the page. That means server provides the page index.html. So web page will be displayed on the client processes, the screen of the client process, client's host. Okay, so here the diagram shows the inter-process communications in the client server model. The client and server, the client makes a request 1 and server provides the response 1, client makes request 2 and gets response 2, and request n and response n. So here the figure shows, the second figure shows the client server distributed computing paradigm. That is, client sends request for timestamp and it gets the timestamp as a reply from server. Okay. The next issue is data representation. The choice of data representation depends on the nature and the needs of the protocol. For simple service such as daytime, used as text mode representation. See here, daytime service, they are giving the example of daytime service, and here this protocol is in using the text mode representation. So data representation is how the data is represented, but here the data is represented in a text mode. See the daytime syntax. There is no specific syntax for the daytime, and the daytime should be just one line. So the one popular syntax is weekday, Monday, year, time, zone. and example is Tuesday, February 22nd, 1982. The time and the PST, the standard time, the Pacific Standard Time. Okay. So here the daytime service means simply it will get a time stamp followed by the weekday, month, day and year and the exact time. So the next one is software engineering for network service. There are two sets of software involved, one for client process, other for server process. Okay, two sets of software is needed, that is one for client process, other for server process. So the software architecture, the diagram shows the presentation. There are three layers at client side: presentation logic, application logic and service logic, and at the server side we have the same the architecture, that is with the three layers: presentation logic, application logic and service logic. So here presentation layer, first one presentation layer. On the server side, a user interface is needed to allow the server process to be started. Typically, a command line execution is sufficient. On the client side, a user interface needs to be provided by the client process. Using such an interface, a user on the client host may request the service and receive response from the server. So at the presentation layer, we have the user interface is provided. Okay, to send request, user interface is required. So it may be simply a command line execution is also sufficient. Okay, so the next one is application logic layer. On the server side, the time of the day needs to be obtained from the system and sent to the client host. So if you take a example of daytime service, the time of the day needs to be obtained from the system and sent to the client host. Okay, on the client side, the request from the user will need to be forwarded to the server and the response from the server will need to be displayed to the user. So all the task is performed here in the application logic layer. Okay, the sending request and forwarding the request to the server and displaying is the response, and sending the response back to the client is done in the application logic layer. So the user interface is given in the presentation layer and the task, the job is done in the application logic layer. There is one more, that is service layer. The services required to support the application are: on the client side, the readout of the server host clock for the timestamp, that means reading the clock, that means the daytime service, it will provide the timestamp. So the reading of the timestamp, the service is required on the client side. So on both sides an IPC mechanism. So this IPC mechanism will provide the acknowledgement on reaching the request or reply. Okay, so the IPC mechanism provides the acknowledgement on reaching of the request or reply. So this is the service layer.